Alright, so we're now in section 10.3. I wanted to go over some of these examples with you with the calculator. It says here, do students who learn English and another language simultaneously score worse on the SAT critical reading exam than the general population of test takers? The mean score among all test takers on the SAT critical reading exam is 501. A sample of 100 test takers who learned English and another language simultaneously had a mean SAT critical reading score of 485, with a standard deviation of 116. Do these results suggest that students who learn English as well as another language simultaneously score worse on the SAT critical reading exam? So first we will state the null and alternative hypotheses. So the null hypothesis will always be a statement of equality. This time the parameter that we are discussing is the population mean mu. So the assumption would be that they have the same mean score, which is 501. The suspicion here is that they score worse, so our alternative hypothesis will be that mu is less than 501. The second part says verify that the requirements to perform the test are satisfied. So let's scroll back and look at the requirements. Right here. A simple random sample has been obtained, the population is normally distributed, or the sample size is large, the sampled values are independent. Okay, so in the question it did mention that there was a random sample and that there are 100 test takers. Now, we can verify that the sampled values are independent by just checking to make sure that the sample size is less than 5% of the population. That is something you can often just take for granted because populations are very large. So we have a random sample. We don't know if the population is normal, and we don't need to know that because the sample size is large. Okay, so we're good to go ahead and run the test. Find the p-value, round to 3 decimal places. So we're going to go into our calculator and we're going to go to Stat, arrow across the top to Tests, and we are now going to do a t-test. The mean and standard deviation are unknown, and that is when you would use a t distribution. So we'll do a t-test, so let's go ahead and enter in here. You have 2 input options, data or stats. You will only use data if you have put data values into L1. We did not do that, so I'm going to arrow across to stats, highlight it, and press enter. Now it's asking us to enter the values of statistics. So that is what we're looking for over here, and that's what we were given in the problem. All right, so let's start putting in some numbers. Mu naught is the mean that appears in your hypotheses, so that would be 501. X bar is the sample mean that was given as 485. S is the sample standard deviation that was given as 116. And then N is the sample size that is 100. Now we choose the inequality symbol associated with our alternative hypothesis. That will be a less than. That one's already highlighted, so I won't change it. And then we go to calculate, and this should give us the p-value. So I have a few things here. I have the test statistic. That's just where the value lies on the t-distribution. Here's the p-value. That's the most important thing that we're looking for. And then it also spits the stats back out for you. So the p-value is about 0.085, so let's write that down. Okay, so part D says using the alpha equals 0.1 level of significance, do you reject the null hypothesis? Okay, so in this case, it looks like P is less than alpha. So when P is less than alpha, this is when we do reject the null hypothesis. We have statistically significant evidence. Okay, so when we state our conclusion, what we found here is that we have statistically significant evidence. In other words, we have sufficient evidence to conclude that people who learn 2 languages, English and another simultaneously, score lower than the general population on the SAT critical reading exam. So let's write this down. There is sufficient evidence to conclude there is sufficient evidence to conclude that those who learn English and another language simultaneously score lower on the SAT critical reading exam. Okay. Let's go ahead and try the next one. This one you'll see is set up a little bit differently. It has actual data values. This only slightly changes how we do the problem. Okay. According to the United States Mint, quarters weigh 5.67 grams. A researcher is interested in determining whether the state quarters have a weight that is different from 5.67 grams. He randomly selects 18 state quarters, weighs them, and obtains the following data. So we have a list of values here. At the alpha equals 0.05 level of significance, is there evidence to conclude that state quarters have a weight different than 5.67 grams? And also, there was a small sample size, so there's a note here to kind of account for that. A normal probability plot indicates the data come from a normally distributed population. So because the population is normal, the sample size can be anything. So the first thing we're going to do is write our hypotheses. The null hypothesis will be that they, of course, weigh the same as our regular quarters. 5.67 grams is the known population mean for quarters. In the problem, we have the word different. The researcher wonders if they weigh differently, that is, that the state quarters have a different weight. So that indicates that our alternative hypothesis will be a not equal to. He didn't really say whether he thinks they weigh less or more, just that they could weigh different. So this is a two-tailed test. So a very low or a very high value could cause us to reject. Okay, so let's start off by going into our lists and typing in the data values. Clear my list. 5.7, 5.65, 5.77, 5.67, 5.62, 5.71, 5.73, 5.73 again, 5.7, 5.61, 5.65, 5.76, 5.7, 5.79, 5.73, 5.67, 5.73, 5.72. Okay, so we have them all in there. It looks pretty good. Just checking over really quick. Looks fine. Okay, so now we want to run a t-test. We go into our stat menu, arrow across to tests, and we're going to number 2, t-test, which is where we test population means. Now this time I'm changing the input value to data by pressing enter. Now you can see that's asking for a list. So we're using that because we just typed data values into list 1. Mu naught this time is 5.67. We did use L1, so I'm leaving that alone. I'm going to change my alternative hypothesis to a not equal to hypothesis. Go down to calculate and press enter. Okay, so it gave us a t-value. It's a positive number. That means our mean was actually higher than mu naught. You can see that here. The p-value is the second thing, 0.014 if I round it. So let's write that down. P is approximately 0.014. Our alpha level of significance was 0.05, so P is less than alpha, so we reject H naught. Okay, so we had statistically significant evidence. This means that under the assumption that H naught is true, it was unlikely to get this sample mean. So because of that, it causes us to not just question H naught, but to completely reject it. So let's write a conclusion. We have sufficient evidence to conclude. We have sufficient evidence to conclude that state quarters have a mean weight, different from 5.67 grams.